Hey, Mike Motta here. Going to talk again about the hacking process and network reconnaissance, how to follow the process and build filters in Wireshark. Again, you need to think like the bad actor and evaluate the target. How can they get target information? Can they exploit the vulnerability once they find a vulnerability? And what is the hack value of the target? So we talked in a previous video about the first phase is reconnaissance, and the first video we talked about using DNS and zone transfers for reconnaissance. In this video we're going to talk about using network mapping tools to come up with what is that information. And again, the easiest one of those network mapping tools is a tool from called NMAP, and it's used for network mapping, and it's from Gordon Theodore Lyon. Network Mapper, or NMAP, basically is used to gain a response from active hosts, mapping their topology, identifying the IP addresses, listening ports, and services that are provided over the network. Again, Network Mapper, or NMAP, was released by Gordon Theodore Lyon as an open source utility in 1997 for network exploration and security auditing. It runs on all the different platforms: Linux, OS X, Windows, and while a comprehensive explanation of every NMAP option and scan technique is not possible, what we're going to focus on is identifying the type of network scans. And again, there are different packet crafting tools that are available that can create similar packets like NMAP. I used NMAP 6.47 running on my MacBook, OS X 13, OS X 10.13, I think .1. And again, I used the NMAP command to just basically ping the subnet. So we're going to take a look at those packets. I also used NMAP on my Windows box, which is technically ZenMap. It's the GUI version, and I believe it's version 7.6 maybe. I'll take a look at that here in a second. But here's basically the trace, and again, since it's local, there's, when you think about a ping scan, it's local. It's not really doing an ICMP ping, it's sending an ARP. And as we see in the trace, we see it ARPing basically up the subnet by IP address. Tell the device that's running NMAP. And as we go down, we'll actually see who has device. Here's 10.10 is at 8F96. So, NMAP, ZenMap, puts that information in its table. So instead of using ICMP, since it's doing a ping scan, since this is on a local network, IP address to IP address, 192.168 to 192.168, it's using ARP, not ICMP. And here's the actual, in this case, ZenMap, and again, I believe this is like version 7.60 is what I'm using here in this case. And when I did this, performed this ping scan, you can see that it mapped all the hosts in the environment. You'll notice there are different scan types. There's an intent scan, which we can take a look at how and what packets it crafts and generates. Again, I did a ping scan. There's intent scan, no ping, slow comprehensive scan. So different types of scans that are available to you, which then obviously if we capture those, we can come up with a profile and build some filters to identify those unique patterns. Okay, so again, I basically did this. In this case, I did the ping scan, and again in Wireshark we see it's basically just sending ARPs. I also did another scan. I'm going to open that up here where I scanned the entire subnet. Ping scan. Let's get rid of the ARP filter there. And in this case, you'll notice it did something a little bit different. So again, if we want to be able to build a signature file or build signature filters looking for these types of scans. In this case, you notice it sends a sync request to port 80 with the ECN bit, which is endpoint capable node, or ECN echo, their bit set, and also the congestion window reduction bit set. So those are sync, ECN, and CWR. That's kind of an odd set of bits there to be set in the sync request, but we see the server say, it's okay, no problem, sync ACK, it agrees. The client then acts, the three-way handshake completes, and then NMAP tears down the session with a reset. So that's kind of an interesting pattern there that we should easily be able to build a filter for. And actually I did that, and I have that filter. I'm going to show that to you. I have lots of filters built here, and I have STs for security. One of those is an NMAP ECN CWR. So this is that particular filter. So we can actually see all of those requests being sent out. And again, you just see what's happening is it's walking up the entire subnet based on identified hosts that have replied, and it tries to start a connection to port 80 with those TCP flags bit set, the sync, the ECN, and congestion window reduction bit set. Max segment size 1460, and with the window set to full FFFF. So that's what I built my filter for, was to look for that particular TCP signature. And sure enough, we find it's, trying to start lots of connections, or it's trying to start connections to those IP addresses, local devices, and it's trying it to both port 80 and to port 443. So I thought that was an interesting signature. Easy way for us to find. And there's a second one I happened to notice that it also, and Wireshark with its coloring rules, kind of helps you find these, that it terminates the session with the reset. We see lots of red in there. So in this case, we see the sync, sync ACK. If we were to follow this conversation pair, if I were to filter for this 6030, 6380, if I right click, say conversation filter TCP, you'll see it actually does complete the connection. So we see the sync with those bit set, ECN and CWR. We see the sync ACK, the ACK, and then it terminates with a reset. But again, the other filter that's kind of interesting pattern that we see is this TCP ACK unseen segment, which I thought was an interesting signature that we can also use for NMAP. You'll notice what it's doing here is it's sending, in this case, a TCP from the source port. Where's my ACK right here? Unseen segment. Source port is 80, and it's sending an ACK packet with no sync. So there was nothing sending a sync request. It's just sending ACKs, sending an ACK packet to that particular, which I thought was kind of an odd way to do things, that it's ACKing an unseen segment. So we see those all throughout the trace. Again, if we just use the color coding rules, we see lots of them happening in this trace. TCP ACK unseen segment. And again, the other rule that makes it easy to see these, if you want to build the filter looking for this pattern, is again the sync, the ECN, and the congestion window reduction. So again, it's just a way for NMAP to find out what hosts are out there and listening, and even potentially what services are open. So I hope that was beneficial and helps you be able to build some filters to identify someone trying to map your network from the outside world. Or you can even do it internally to find out and help yourself to understand what resources are available and what applications are running on those resources. So again, thanks for your time. Make it a great day.